I can't screen share today, but we'll be switching between some of the slides and video of me showing you some of the components of what you're going to put together for the electrolysis demo. It's not very difficult to set up. It takes a minimal amount of science equipment. A lot of this is really easy, accessible things that you have already. But there are some things you want to consider when you're setting up demonstration for your students. If you could, I'm not sure if am I on the main screen right now. We have the slides up. Okay, we have the slides up. So we can see two images of the setups. The one on the left is one that I set up with basically the minimal amount of materials. You could even probably get away with less materials here on the right. But the demonstration involves a battery, some sort of cup, some test tubes, or you could use graduated cylinders, some water, baking soda, and a 9-volt battery. If you could advance to the next slide. So the basic setup is this, and you might need additional equipment to help you set up, and I'll show you a little bit of my setup here in a moment. You need the 9-volt battery, you need some thumbtacks, you need those test tubes, you need some sort of container. And if you can switch to my video, or not this video, my screen, I guess, the highlight on me so I can show some of these. Thank you, perfect. All right, so I have a setup right here, and I'll try to bring it into screen here. You'll notice that I have a ring stand and several clamps that are holding my materials together. We'll talk about this cloudiness in just a moment. But what you're going to set up with this demonstration is you're going to take a plastic cup, and the wider plastic cups, or maybe a deli container that has a little bit of depth, are very useful. You're going to take some thumbtacks, the kind of thumbtacks where you have that big round metallic surface. You're going to press those into your deli container or to your cup. I recommend, if you are using test tubes, these test tubes are going to capture the gas from the electrolysis of the electrical current passing through the water, breaking the water molecules into hydrogen gas and oxygen gas. Take those test tubes and maybe kind of eyeball them and put them into your cup before you press your tacks in, so you know that they're lined up. Also, you're going to want to line them up with the battery. So these battery terminals will come into contact with the tacks to provide that electrical current between them. And you can press them right into the cup. You don't have to worry about gluing the tacks in. It's been my experiences that in this kind of plastic cup or a deli container, the tacks produce a seal that's good enough to keep water from dribbling through. So once you have your initial cup tack container set up, you're going to need to mix some solution. I have some recommendations for that solution. The instructions are going to talk about using baking soda or Epsom salt. Just eyeballing the amount of baking soda into water. I also recommend that you use distilled water. I think you can get better results if you use distilled water, and I'll explain why I think that is in a moment. You're going to mix a solution. It's an approximate scoop of solution in, so you don't have cloudiness, but you want enough of the baking soda in solution to help the electrolysis move through with, I think, essentially electrolyte. And then you will lower those test tubes on top of the tacks. There can be a little bit of opening between the tacks in terms of the water, as we saw in that schematic earlier. And you'll collect the gases that are going to be produced into the test tubes. When you collect the gas into the test tubes, you do need to use kind of a displacement method. So topping off your test tubes, using smaller test tubes that you can put your finger on top of to keep any air from slipping through. You'll want to do a kind of a full test tube, cap with your finger, put it underneath the liquid level so that you can have a full test tube of water Doesn't even need to be the solution, but a full test tube of water. You'll do that twice. That's why the wider container is helpful in getting and working in there. But a cup like this works. And then once you have those test tubes in with a clamp, or we saw in the other pictures, some rubber bands holding things together, you can bring the battery into contact with the tacks, and then the gases will be produced. Lindsay, if you could go back to the slides for just a minute. And go back one slide to the pictures, so the setup. Now, what will happen, and I think the picture on the right does a little bit better job of showing what's going to happen, the reaction. Gases will be produced at those terminals of the tacks. The gases will travel upward into your test tubes. On the right side, we can see there's a volume difference. On the left side, and that setup, it's equal, probably just from some sort of slippage of the some air getting in. But we can see a volume difference, and that volume difference should be 2-to-1 volume difference. So you are producing twice as much hydrogen gas as oxygen gas, or twice as much H2 as O2. This isn't really a lesson on, say, the chemical reaction that's occurring here. What we're really concerned with is just breaking the water molecules into their parts, the hydrogen and the oxygen. So we should see a differentiation between that, twice as much hydrogen to oxygen. If you would like, and you can switch back to my screen, if you really want to show that beyond just kind of a qualitative demonstration, using small test tubes, or excuse me, small graduated cylinders, maybe about this size, you can remove that kind of stand cap and use those instead. If you have enough apparatus to kind of hold things together, can be used. I don't recommend anything this big, because you have to produce quite a bit of gas, because these cylinders don't really start grading up until about 3 or 4 mils. But if you use the smaller test tubes, they'll fit into the container. Depending on the mouth, this test tube's graduated cylinder is probably better because it has a smaller mouth opposed to the big mouth. But just kind of looking at and trying and seeing what works and what's going to fit with your setup, you can show, by volume of gas, all things being considered, you should have twice as much hydrogen gas to oxygen gas. Now, what do you do with that gas? How do you know you're producing hydrogen and oxygen gas? And this is in the lesson, but you can do a splint test. I have a quick video that's going to show you, and you probably already know what's going to happen when we add flame to hydrogen gas. Lindsay, if you can show that quick video clip. I did this today, took 10 minutes of gas collection. So we see that that gas, the hydrogen gas explosion, quote unquote. I think you get the best results if you have the kid either hold the test tube or put the splint in, because you can get a little bit of a jump. You also test the oxygen test tube, and you can close this video down. You test the oxygen test tube as well, and you can take a kind of smoldering splint, and you should be able to get it reignited. In terms of the volume of gas you need to do that, I would say on a small test tube, if a test tube maybe the width of your pinky, you're probably only going to need maybe less than an inch of hydrogen, maybe 5 mils of hydrogen. Anyway, if we can go back to the PowerPoint and look at the slides, that tips slide. So there are some things that I recommend that you consider when you are preparing the demo. Of course, practice, try the demonstration yourself. One of the things that you probably have access to are already 9-volt batteries. They've probably been used over and over and over and over again. They're probably not fresh. You're going to get better results with fresh 9 volts. You only really need one. So I recommend you get a fresh 9 volt for this. You can use graduated cylinders, of course, to collect a quantitative amount of gas so you can do that comparison. I do recommend using clean, quote unquote, clean glassware between demonstrations if you have multiple sections, distilled water. I showed this setup and you might see me on the small screen earlier. You can see there's a cloudiness that's formed in here. I'm not sure what this cloudiness is from. The first time I run the demonstration, every time I run the demonstration, I can have pretty clean results. I don't get a cloudiness in that container. There might be things that are dissolved either in the water, if I'm not using distilled water from my school's water supply. There's corrosion that forms on the end of the thumbtacks on where the oxygen is being formed. I think the oxygen might be reacting also. I've had some experiences where I've formed a green cloudiness, maybe dirty test tubes, and the oxygen that's being produced is reacting and producing something in solution to give it a green color. So I recommend using clean glassware between demonstrations and distilled water if possible. And the last piece, which is mentioned in the lesson, is if you want to help the students visualize these molecules, there's a really powerful free tool on the web. It's called MoleView. And MoleView will allow you to use a search, and it's browser-based. It will work with modern browsers, and you can create 3-dimensional models, and it's got a lot of powerful tools with it, but just the visualization, the ball and stick visualization models are helpful for your students to recognize these structures and how molecules and atoms are related to one another.